everybody. In this video, we're going to be going through an example stormwater runoff calculation question. So what I got here is the TI-84 calculator emulator. We're going to be using this, as well as I got my notes here. And then here's our problem. Also additionally have the PLTW engineering formula sheet. If you end up searching for 15 stormwater runoff, if you even type that in, you can end up finding that. So let's go ahead, let's begin. Question number one. So we have this case here for Q pre where we're starting off with forested 5 acres of land, and then for Q post we're adding in a 1.5 acre cemetery, and then the forested land is going to be 3.5 acres. So let's continue to our problem statement. So suppose a developer purchased 5 acres of forested land in Nashville, Tennessee. A 1.5 acre cemetery will be placed on the plot. Local regulations require that post-development runoff be limited to pre-development runoff for a 100-year, 2-hour rainfall. Find the change in peak runoff, which is basically the difference in the pre-development and post-development peak runoff. So let's go ahead, let's get ready to begin. Let's start with what we know. We're going to have Q pre. Now since Q pre is simply just the forested land, it's going to be CFCIA. Okay, so let's go ahead, let's begin with Q pre. So they tell us that the acreage here, A, is equal to 5 acres. Now what we've also got to determine is CF, C, and then I. Now C is dependent on our surface type. I is dependent on the magnitude of the storm, right? That's the intensity. And then CF is also dependent on the magnitude. Let's go ahead, since we already wrote down A, let's work our way back. So let's go ahead and let's find I next. So what we can end up doing is in this worksheet, we're going to actually have this information here, which is an intensity chart here for Nashville, Tennessee. And so in our particular scenario here, we have a 100-year, 2-hour rainfall. And so what we can do is we can find that 100-year. Then we want to follow that down to the 2-hour row. So 2-hour row, so 100-year, 2-hour, 1.83 is what we got. So 100-year, 2-hour, yep. So that is 1.83. So what I'm going to do is I'm going to write down for our I, 1.83. Remember the unit for this is inches per hour. Now let's go ahead and continue. We've got C here. Now as we said, this is forested land. So if we end up going in here, what we can end up doing is we can search for the rational method runoff coefficients. You can also end up typing in forested. It'll end up showing you that. And so as we can see, we have this range here. So I'm going to go ahead and start by writing down this range, 5.9 to 0.2. And so what we're going to actually end up doing is we're going to find the average of this. So we can go 0.059 plus 0.2, divide that by 2, right? So now we can find out what our C value is. And so what we're going to do is we're going to bring up the handy dandy TI-84. And then what we can do here, let's go ahead, click clear. So 0.059 plus 0.2. Press enter, divide that answer by 2. We end up with 0.13. So we're going to round that to the nearest 100th place. So 0.13. Finally, we've got to find CF. So if we end up looking here, we can see CF based off of the magnitude of the storm, right? We said it's a 100-year storm. So CF, the coefficient, runoff coefficient adjustment factor, is 1.25. And so now what we can end up doing, we know the acres, we know the intensity, we know C, and we know CF. We can simply plug this in for Q pre. So Q pre in this question is going to be 1.25 multiplied by 0.13, which is C, multiplied by I, which we ended up finding to be 1.83, and then multiplied by A, which is our acreage. And so now what we can go ahead and do is bring up our TI-84 again. And now we can take 5 times 1.83 times 0.13 times 1.25. So now we end up with 1.4, and let's call that 1.49. Remember, this is cubic feet of water per second. So that's our Q pre value. Now it should be the case that Q post does not exceed this number. All right, so we're going to go ahead and find that out. So let's go ahead and calculate out Q post in this case. Now keep in mind, for Q post here, just as we can see in this previous slide, it is 1.5 acres now of a cemetery, and then it's 3.5 acres of the forested land. And so what we've got to take into consideration here, Q post is going to consist of the Q of the cemetery, and then also the Q of the forested land, right? So I'm going to put an F on there for that. So what we've got to do is we've got to calculate out the Q value for the cemetery, and then separately calculate out Q value for the farmland. Then we're going to add those values up, okay? Now, one thing to keep in mind, I, for this whole entire problem here, just this problem, I is going to remain the same as well as CF, okay? So let's go ahead, let's begin, let's break this down. So Q cemetery is what I want to calculate out first, okay? So this is going to be CF, CIA. It's going to be a specific C value for the cemetery and also a specific area for that cemetery. Let's go, just same process as before. The area of this cemetery, just as we can see here, is 1.5 acres. And then what we can do is we can write down our I value. I is remaining the same throughout this problem. So ours. C value, that's what's going to be different. So we said that's for a cemetery. So what I can type in here is cemetery. So cemetery. So just as we can see there, it's 0.1 to 0.25. So it gives us that range. So what we can end up doing is 0.1 plus 0.25, right? We're going to find the average, divide that by 2. And so what we can end up doing, bringing up the good old calculator here, we've got 0.1 plus 0.25, which is going to be 0.35. Divide that by 2, we end up with 0.175. And so we can end up using that number if we want to be pretty precise. And then finally, we've got our CF value, which is going to remain consistent throughout this problem because it is still a 100-year storm throughout, right? Same magnitude of storm. So now we've got all of these values. What we can then end up doing is basically plugging all of this in. So this is just 1.25 times 0.175 times 1.83 multiplied by 1.5. So let's go ahead and do that on the calculator. 1.25 times 0.175 times 1.83 times 1.5. We're going to press enter. What we end up finding is just from this cemetery alone, it's going to provide 0.6 cubic feet of water per second for the peak runoff. So we found out Q of the cemetery is 0.6 cubic feet per second, right? Now we got to find out the Q of that farmland. So I'm going to go ahead and pop it down here. QF equals CFCIA. Now the only thing that's different here is the area is going to be, instead of initially 5, it's going to be 3.5 here. So we can go ahead and write this down, 3.5 acres. And then we've got I here, which is remaining consistent, it's still 1.83 inches per hour. Then we've got C. The C value we're going to be using here, since it's for farmland, we're going to be using this value up here that we ended up calculating, 0.13. And then now for the CF value, just as we said before, that's remaining consistent throughout the entire problem. CF and I do not change throughout a single problem. So now what we can do is we can calculate out this Q of the farmland. So CF is 1.25, multiply that by C, which is 0.13, multiply that by I, which is 1.83, then multiply that finally by our acreage, 3.5. And so now what we can end up doing is we can end up multiplying these out here. And so we can go 3.5 times 1.83 times 0.13 times 1.25. And so now what we'll find out is the Q value for the farmland in this post-development situation is 1.04 cubic feet per second. And so now what we've got to do is we've got to add up this. So we said Q of the farmland, or sorry, Q of the cemetery plus the Q of the farmland in the post-development is going to be Q post. So we got to add this 1.04 cubic feet per second. And so now whenever we add that, we got 1.04 plus 0.6. What we're going to end up with is 1.64 cubic feet per second. Okay, so this is Q pre, this is Q post. Let's say that we want to end up finding the change in Q. What that is basically we take Q post minus Q pre. And so it's just the difference between these two numbers. So if we end up calculating that out, we take that 1.64 minus 1.49, we'll end up finding the difference is 0.15 cubic feet per second. So basically we're going to have 0.15 cubic feet of water per second leaving this property because of the fact that we added in a 1.5 acre cemetery. So based off of that, as we were talking about in class, we could add in a retention pond, we could add in extra vegetation, maybe we change the slope or the topography of the land. There's many different things we can do to combat this extra 0.15 cubic feet of water that's leaving per second on this land. Anyways, hope that video was helpful. Catch you all in the next one. Deuces.